Let f is a function defined from real to real be a strictly increasing continuous function, and if an is a sequence in closed interval 0 to 1, then the sequence f(en) is. Means this type of question is somehow you can solve by sequential criteria or continuity of the function. So look at the options. This is first option increasing, this is bounded, convergent, and not necessarily bounded. If one option is true from B and D, then other will be false. As you can see, option B and D. So we check option one by one. So for option A, as what is given, f is strictly increasing continuous function, and an is a sequence in closed interval 0 to 1. So consider sequence a n as 1 by n, and we know that this is a decreasing sequence and converging to 0. So decreasing sequence, so if n1 is less than n2, then 1 upon n1 is greater than 1 upon n2, means this value is lower and this is higher value. As function is strictly increasing, it means that function will be at a lower value, image of that will be somehow lower or below the coming point. So f of 1 upon n1 is greater than f of 1 upon n2. This means that sequence is in 0 to 1 and f fail at its monotonicity, means as function increasing strictly increasing, but here you can see this is true, but this is not true, means hypothesis fail at this point. So option A is not true. Now come to the point, option B, as function is strictly increasing, it is given, and this is sequence an is in interval 0 to 1, means strictly increasing means function has extreme point at its endpoint of the domain. So means function will have minimum value at left endpoint, function have minimum value at left endpoint, and function will have max value or maxima at right domain point. So function will be bounded, because if this will be true for any sequence that is in 0 to 1, means if domain is bounded, then function image of this point will be bounded. So fan is bounded for domain point. It means we restricted the sequence is in 0 to 1. If this condition is not given that sequence is not in 0 1, that it is not necessary function will be bounded, because function is strictly increasing over the domain R. So it may or may not have lower point, or it continuously decreasing and increasing, means minus infinity to positive infinity. But as we restricted the domain 0 1, so function will be bounded. Now come to the point C. Function fan or sequence fan will be convergent. So if we consider any discrete sequence, means sequence which is not jumping type sequence, means 0 1 0 1, this type of sequence, then f of, and consider function is identity function. F is identity function, and identity function we know that in interval for interval 0 to 1, this will be strictly increasing, but f of for identity function f0 will be 0, f1 will be 1, and again the domain point f0 will be f1 will be 1 and f0 will be 0, means uh, image of the domain points, image for domain points of the sequence is not convergent but bounded. Again, this is bounded because we have lower bound as 0 and you can see upper bound is 1. For identity function is identity function, and sequence is this. So you can see that again function is bounded but not convergent. So this option false. And as we discussed in the starting of this solution, if one of the option is true from B in D, then other will be false. So option D discard here automatically. So this is the way how to proceed this question and find the solution.